Out where I put all the old ones. What's up? You're not in it. What's up?
Jackson, you
I gotta figure out what I'm gonna do with that.
good?
All right. So, first things first. Even before we get to this, I'm going to talk a little bit about the test y'all just took, because it was bad. Like, just glancing through it. We gave an extra day on Friday. A quick question: how many of us did any extra check your understanding questions? Taj did. Adriana did. Okay. At the end of class, I want y'all to get them out. I want you to show them to me. We're going to claim we did them. I want to see them. Okay. Say again.
I write on paper box.
The check your understanding of the fair models?
She did do them on the board at the end of class. She was working through them.
Okay.
On
We need to write them down so I can have evidence of them in the future. But I want to glance quickly at some of the fair model check your understanding questions. So transforming function shapes. This is the very first one. Did y'all have any questions on that test where y'all had to take 3 lines and multiply it to see what the function looks like?
Oh yeah, we did.
Definitely did. Would it be similar to if we had a quadratic multiplied by a linear? Yeah. I'm going to record this. I'm going to upload this video as a quick review because the reality is some of y'all need another chance to show me proficiency. So I'm going to put these questions on the upcoming unit, demonstrate understandings and test, just like the solving equation. So I'm going to quickly go through some of this. And so I need us to pay attention. Like if I'm looking at this, what type of functions, what type of polynomials are we starting with? We have what? We have linear, right? We have 3 linears. Which is going to give us what type of function at the end? A cubic, right?
Yep.
Because it'll have how many zeros? 3 of them. Guys, either we're not taking the time to think through this or we have not learned what we need to learn, but like, we have 3 zeros. That's it. And those are my 3 different regions. And so how many times should our function, our resulting function, intersect the x-axis? 3 times. Okay, now when I look over here to the left, we need to recognize those factors. Are they positive or are they negative? Describe them by the color.
Red is negative.
Red is negative. What else do we have?
Negative. And black is positive.
You said blue is negative?
Yeah.
Notice, for any of us who didn't realize this, yeah, it keeps going, doesn't it? And black is positive. Okay, what's a positive times a negative times a negative?
Negative. Positive.
Oh, so everything to the left here is... We act like we couldn't do that on that test.
You get that wrong.
Like that's it, guys. We've been doing that for weeks. When I look in between these 2 zeros, red and black have what type of factors? Positive. Blue has? And what's a positive times a negative? Okay, which makes sense because what type of root do we have right here? It is a... No, what type of root?
It's
Single, double, triple?
nope, it's a single.
It's a single root, so it goes through there. Into the negatives. We come back to our 0. Then I look in between these 2 zeros. Negative, negative, and positive. What do I get when I multiply that? A positive. So it makes sense again because I got a single root. Into the positives, comes back down. Positive for red, positive for blue, negative for black gives me. That's it. That was half the unit right there. That was half the test, essentially. We're going to talk more about some of these other things in a second. But in a similar way, when I take a quadratic times a linear, what type of polynomial do I get? Another cubic, because how many zeros do I have? 3. Yes, ma'am.
oh, I just need to show it.
Okay. In this case, though, I only have 2 factors I got to worry about, which is nice. But still 3 zeros. What's a positive times a negative? Negative. Negative times negative.
Positive.
And I'm rushing through this, sure, but like, that's because we've been doing that for a couple weeks, a few weeks. Like, it's identifying positives and negatives, it's identifying zeros. Because what property is it when you multiply by 0, you get a 0? Zero product property. That's the y. Don't tell me that you can set it equals 0. We need to recognize that anything times 0 is 0. So wherever a function, a factor has a 0, the new function has a 0. And it's either going to be positive or negative in those other regions. Yes, Ms. Kowalski?
We also, a lot of us made double roots out of, like,
Yeah. But all those are singles.
yeah.
They're all single roots. So are they bouncing at all? No. Which is why it goes from positive into negative. We got to pay attention to the multiplicity. Okay? I should have done the medium one on this, but I chose the spicy one here. Like, in this case, we already have what type of function? We already have a quadratic. So if the reason I chose this one is to write the final dilated function. So let's just say what I have already is f of x, and I'm dilating f of x by what? Times x minus 3. Do I have that x minus 3 yet? No. So we got to know how to graph a line. How would I graph the line y equals x minus 3? You need to recognize that's a line. How would I graph that line? The y-intercept is negative 3. 0, 1, 2, negative 3. So my slope is understood to be 1, right? So up 1 to the right 1, up 1 to the right 1. Does anyone know another thing I could do to find the equation or that graph pretty easily? Something we've done a lot this year? How can I find my 0 for this? Well, I don't need a 0 product property. I don't have a product up here, but set that factor equal to 0. Notice it's not quadratic. It's not a higher degree polynomial. It's linear. What do I do to solve that equation? At 3. So what's my x-intercept?
3.
Oh, well, that makes sense if it's going up 1 to the right 1, doesn't it? Actually, I need to just draw that factor. Once I have my factor drawn, it's exactly what we've been doing. Positives and negatives to multiply it. That's it. A medium one here. Here was multiplicity in standard form. We actually had to solve some of these equations. Now, I want to pause and I want to point out two things because I was trying to give you all an easier set of factors on the test, but I believe I gave you all something like, this is not exactly it because I need us to see those things later when we come back. But let's say I gave you this equation. I asked you to solve that equation for the zeros. What would you do first? So set each factor equal to 0. Okay, what would I do here? Add 4. So multiply by the reciprocal or just divide by 3, either way you want to say it. Because here's the thing I need y'all to understand is like, you can talk it out when I ask you, okay, then what? I didn't even tell you what to do next. That means you need to take the time to say, and then what? Like, that's it. And what next? Like, what is the next thing to do to get to the end goal? You know how to do that. Now, we need to pay attention to x squared minus 25 equals 0. What am I going to do? Add 25, okay, cool. X squared is equal to 25. Now square root both sides. Now, don't anyone say anything. I'm going to show you the most common mistake that Ms. Kowalski just saw. What's wrong with that? It's not just like, I don't see anything wrong with that.
No, I understand it.
Oh. Anyone see it now? I mean, square root's the inverse of the square though, isn't it? Let me point this out. How many zeros should this have? How many zeros should this have? For a total of how many zeros? How many do I have?
2.
Where's my third? Is 5 squared the only thing that gives me 25? What else can I square and get a 25? Guys, when you take a square root, it's a positive and a negative 5. Calculator can't tell you that. You got to think through that. When you take a square root, it's got to be a positive and a negative 5. You've got to attend to that detail. You got to recognize, slow down, and realize, hey, I need 3 zeros. I'm missing 1. Notice how this question and this question elicits the idea of solving a quadratic equation, right? Wasn't that unit 3? We just finished unit 4. Like, we got stuff to learn. We got 3 to 4 weeks left. I don't care who you are. I don't care what the background is. If you give a crap and you want to grow and learn and you want to master this before the end of the class so that you can pass this class, you can do it. But we got to step up and we got to actually learn these things. Like, I know that we're used to classes where if we just are nice and we don't cause a problem for the teacher that we pass. But like, I care too much about you and about your future to let that be the case. You got to learn something. I care too much about you. And more importantly, I need you to hear me on this, I know that you're fully capable of all these things. Jack, it helps when you stay awake. Jack, it helps when you stay awake to learn. You're intelligent human beings. You're juniors in high school. Hard work pays off. Thinking pays off. And we got to step up and we got to do these things. This is not brand new information. This is what we've been studying for months now. Or well over a month. On this one, identify the zeros, the degree, domain, range, and extrema. Now in standard form, I'll go ahead and tell you, you can't identify the zeros from standard form unless you have it graphed. But in factored form, use your zero products property. Domain and range, you have to have a graph. But I need us to recognize, like here, for domain here, what do we mean by domain?
All the x-intercepts you use.
Not x-intercepts, x values, also called, there's an I word, inputs. And that's important because x values is only on a graph, but you can always have a domain, and domain doesn't always have to be x, but it always needs to be inputs. Does this ever quit going to the left?
No.
Down here, does it ever quit going to the right?
No.
So what's my domain?
Infinite.
Negative infinity is the minimum to
Positive.
positive infinity is the maximum, right? It goes all the way left, all the way right. Range. What do I mean by range?
The y value.
The y values or
Y input.
the outputs, the y values or outputs, right? Does it ever quit going down?
No.
So my minimum y is, maximum y is, like, we gotta justify it, but we gotta understand x values and y values, inputs and outputs. Graph over here. We're going to study this more, by the way, in the next unit. Please understand, what we're always doing is we're always building. And so like we're going to continue to use the ideas that we just learned. So that gives you more chances to master these ideas. If you have questions about these old ideas as we study new ideas, you need to ask those questions, either of your group or of myself or Ms. Kowalski over the next day and a half that we have left with her. Okay? Right here, when I look at this, I'm just going to go ahead and jump on the domain, negative infinity to infinity, but I want to focus on the range here. What's the lowest, because remember we always start with a minimum, what's the lowest y value or output? Negative infinity. Notice, does it ever actually quit going down? Okay, what's the maximum y value? Kind of just counting 1, 2, 3, 4, 5, 6, 6-ish. Now I think this actually goes up to 15, so this is 14, this is 12, which is where it's really helpful to have a calculator. But if you actually look, it goes a little bit above 12. Remember, we showed you how to use the calculator to get a more precise y value. I don't know exactly what it is, but I'm guessing it's somewhere around 12.2. But you can get a more precise value. Now notice, does it actually have whatever that actual y value is? It doesn't actually get there. I mean, that's a point, isn't it? So does it have that value? So I don't use a parenthesis, I use a bracket. Okay? We're going to continue working on these things. Now, I need to pay attention to this next detail because we're going to use this in the next bit. I need us to recognize here, this doesn't have one maximum. It has what's called an absolute maximum, but it also has a maximum here. It has a minimum here. 2 max and 1 relative min. Over here, this one has 1, 2 relative min and 1, 2 relative max. Those are what we also call terms. Okay? I say that because of the activity that I already passed out to you. Alright, so here's what we're going to do. I'm going to have you do the self-assessment on the proficiency scale tomorrow to start class. But with unit 5, like we have two different proficiency scales because I didn't want to put it all on one, but it essentially is a lot of the same exact stuff, right? So polynomial functions starting with an equation. Oh, that's weird, Jordan. How'd that happen if you don't have your phone?
I ain't saying have it today.
Oh, so you didn't lie to us today?
I ain't letting you do it.
Jordan. Thank you, sir. So, we've got these details on that we're trying to master, right? So leading coefficient, domain and range, hopefully that sounds familiar. Polynomial function and forms, that should sound familiar. Degree, fundamental theorem of algebra, zeros, roots, and x-intercepts. And then we're going to be identifying these things. Have we solved quadratic equations to determine zeros? Yeah. Have we multiplied factors to determine the standard form of polynomial function? Have we identified the degree and leading coefficient of a polynomial both in standard and in factored form? Sounds like almost. What's the one thing we haven't done? We haven't done leading coefficient yet. We're going to talk about that more today. Alright, but here's what we're going to focus on, and I need you to notice this. We're going to determine the possible number of x-intercepts using the what? The number of extrema using the degree. The in behavior of a function and with proper notation. We'll talk about that soon. And we're going to build polynomial functions. We're now moving beyond relative extrema to also include absolutes. We're going to talk about what's called a quartic function and a quintic function. I'll explain that more later. Alright. So a lot of the same stuff with the second one. This is 5b, I believe. But I'll explain more of these things. Some of these you can actually take off. If yours says determine domain intervals of increase, decrease, you can, no, we need to do that. No, I'm not going to take that one off. Or you can take off the calculate the average rate of change. We're not going to do average rate of change. So on the 5b where it says average rate of change, you can take that piece off. Alright, so what I want you to do is I want you to look at this equation. And I want you to look at this equation. And I want you to talk about it with a couple of people around you. And I want you to identify what you think might be the leading coefficient of f of x and of g of x, and what you think the degree of those two functions might be. So talk to the people around you a little bit after you get a second to think. What do you think the degree of those two equations are? What do you think the leading coefficient of each of those equations are? That's what I want you to think about. I want to see what y'all remember. So what are y'all thinking?
What's his name again?
The highest power. Okay. Think what you think coefficient might be. What are you thinking? Say again. Four is the leading coefficient?
No, like,
Where's the degree?
yeah.
What is? Okay, so what do you think for both of them? Which one? Yeah? Okay. Alright, let's talk about it. So degree, what do we think the degree for f of x is? The degree is 4? Okay. What do we think the degree is for g of x? Okay. Someone from over on this side of the room, because I hear people over here answering it. Do y'all agree degree is 4? Yes? Taj, what do you think? Aiden says yes? Yes, why is the degree 4 then? What are y'all thinking? Highest power? Highest power? Does anyone want to add on to that, or is that what we were thinking over here? So highest power, so the highest power is 4. So highest power for both is 4. Okay. All right, so any guesses what the leading coefficient for each of these is? So 3 here, and thinking leading coefficient here is -5. Anybody want to push back on either of those responses and have an idea why? You think it's 3? You think it's 3 for g of x as well? Okay, but you agree 3 for f of x? Okay. So, first off, what do you think we mean by leading coefficient?
The first one.
So, something that's leading is what's first, right? What do we mean by coefficient? Co does mean with, but it's more than just that with mathematics. Coefficient. So the first number with a power, but so I'm not asking leading coefficient. I just mean coefficient. Like for example, what's the coefficient here? This has a coefficient. It's not a 1. It's a 2. What's the coefficient here? -5. What's the coefficient here? What's the coefficient here?
2, 3.
Okay, so what's a coefficient? It doesn't have to be a whole number, so like in this case, what's my coefficient? 3/4, or 3 divided by 4, right? 3/4. So what is a coefficient?
A number accompanying an x.
So a number multiplied by a variable term. Okay, yeah, I'll say term. Yeah. So like in this case, notice 3x squared y, what's the coefficient? 3, right? Like that's all a coefficient is. It's the number being multiplied by a variable. Let's say expression. Say it like that. And technically in a single term. So, by the way, I will point this out. Does anyone know how many terms are up here? There are 4 terms, right? So each term is separated by addition or subtraction. So we got 4 terms there. Now, leading, it sounds like we're thinking is what's at the front or at the beginning, right? So, Jaden, why did you say 3 for g of x then? Because it's the what? So because this number is bigger than 2? Okay, so what if I change this to a 7? Do you think it's now 7 or is it still 3? You think it's now 7? Okay. I will say for sure, let me confirm this then. In f of x, the leading coefficient is 3. Okay? So degree is about the highest power.
Even after you change it.
Even after I changed it, f of x, the leading coefficient is 3.
So it'd be 3 for g also.
Why do you think it'd be 3 for g? Why are you changing it from -5?
You just said that.
No, I'm saying f of x has a leading coefficient of 3.
No, you just said that
You're still thinking
the
-5?
highest, that's the highest power.
Wait, the highest power down here is what?
4.
4. I want to point something out. I want to come back to this in a second. So put a pause on this. I want you to think about this. Does anyone know what the relationship between f of x and g of x are?
3x.
Like, if I were to graph these two, they are the same, so they would be equivalent. Interesting. So if the leading coefficient here is 3, what does the leading coefficient here has to be? It has to be 3. They're equivalent, right? So when we say leading coefficient, I'll set everything up in a second. When I say leading coefficient, it's not just the number at the front is Number multiplied by a variable expression with the highest power. We need to recognize that. Okay? I have Fourier models for you for the rest of the unit, but I want you to write this information down. Hold on, I haven't given the Fourier models out yet. That's for last unit. What I want you to get out is the highest power mathematic activity that I passed out. And I need you to write these notes about what degree is and what leading coefficient is, because that's going to matter a lot tomorrow.
I did pass out the Fourier model.
Oh, did you?
Yeah, was I not supposed to?
Never mind. You got the Fourier models? That's fine. If you want to write it on there, you can do that. Yep. So, no, that's totally fine. I didn't think I'd already passed them out. Degree is the highest power. By the way, it's the highest power in what form?
Wait, which part did you say the was again?
Say it one more time.
Which part did you say the was?
I was saying to put it on the highest power mathematic activity, but you can also put it on the Fourier model. The mathematic activity is on your right-hand side there, underneath your blue, Samaja. I think it says highest power at the top, doesn't it? I was saying you can make a note over there. It's the highest power in what? Standard form. Remember, it's going to be the sum of powers in factored form, right? Essentially, count how many zeros you got. Because what really important principle that was on your test tells us the degree matches the number of zeros? Fundamental theorem of algebra. Guys, you got to remember that fundamental theorem of algebra tells us an nth degree polynomial has n roots. So a 7th degree polynomial has 7 roots. A polynomial with 6 zeros or roots is what degree? 6th degree. Okay, that's where we'll end today. So obviously we do not get to the mathematic activity. When I pass out cards tomorrow, that'll be your group for the activity. Hey guys, I am frustrated because of what we're seeing on this test, but I need y'all to understand you're still capable of amazing things. But we actually got to learn it. Like, there's a lot of us that are showing us in class that we can partially do it in the groups, but if you do not take the time to actually practice to check your understanding to solidify it on your own, when you get to a test where you have to do it on your own, it's going to be a problem. You've got to take the time to actually practice it on your own. You're capable of amazing things. Let's do the work to get there. In my class, it doesn't matter when you learn it, it matters that you learn it. But it does matter that you learn it. Alright, you can pack up, get into advisory time. You did not finish your test. You might be able to